Hey everybody, we are going to be working with another exciting lesson on inequalities. I know you thought they were going away for good, but nothing in math ever goes away for good. So here we are with this problem that this week Mr. Duncan needs to eat dinner at a nice restaurant. The dinner, including tip, is going to cost $40. So you need to graph the inequality that describes how much money Mr. Duncan needs to have in order to make this work. Great. So what we're going to do here is we're going to come up with our variable. I'm going to use M for Mr. D's money, Mr. D's moolah, and I need to just graph the inequality that describes how much I need to have in order to not be embarrassed and have to, I don't know, wash dishes to pay for my dinner. Okay, so clearly that means to say that I need $40 in my wallet or more. $40 will work, anything more than that will work, so my inequality is going to be M is greater than or equal to 40 or $40, however you want to talk about it. So I'm just going to put 40 at the center of my number line here. I'm going to put one number on either side. I'll do 35 and 45, and then I'll switch colors. How about red? And we'll graph this. M has to be centered at 40. It can equal 40, so I'm going to fill this in. And it has to be either equal to or bigger than. So I go to the right, and I'm done. Super simple. Just a word of warning, the rest of them will not be as simple. Next week, Mr. Duncan wants to take Mrs. Duncan out to eat dinner at a nice restaurant. The dinner, including tip, is going to cost $80. Weird how that works, 40 times 2. Graph the inequality that describes how much money Mr. Duncan needs to have with him and how much Mrs. Duncan needs to have with her in order to make this work. So now I've got two variables, and I'm going to graph this with an XY plane, or more specifically, with the two variables I'm going to pick right here. How about M for Mr. Duncan, Mr. Duncan's money, and we need something else for Mrs. Duncan. How about P for pretty? My wife is pretty, so how about Mrs. Duncan's money is going to be represented by P. Okay, so now what I need to do is I need to graph all of the situations that will work here, how much I need, how much Mrs. Duncan needs in order to make this work. So I'm going to graph this on an M and P plane. And it turns out, if you read the question carefully, that what I need to have happen is I need to have $80 because I am taking my wife out. It doesn't say anything about that she has to pay for anything, so it really doesn't matter how much money she has. So my equation is going to be simply M is greater than or equal to 80. So there are two variables here, but it doesn't matter what P is. P can be anything as long as M is greater than or equal to 80. So let's go ahead and count off. How about by 20s? We'll count that one 20, skip the 40, 60, 80, and 100. That's a 100, everybody. Okay. And there are the tick marks. And then P is going to be measured by the same 20, 40, 60, 80, and that's where those are. Okay, so now all we have to do is graph all the times where M is greater than or equal to 80. Now you don't know how to do this yet, but you should know how to graph where M is equal to 80. And notice M is where we normally put the x-axis, so this is the same thing as trying to graph x is equal to 80 on an xy plane. And you should know by now that that is a vertical line where x equals 80. So it should be something like this. Okay, don't forget to label your graph. This is M greater than or equal to 80. Okay, and because this is a new thing that you don't know anything about yet, there is one more thing we need to do. This will make perfect sense by the end of the day. It might make no sense right now. What I'm going to do is I'm going to shade everything on this side of the line and nothing on the other side of the line, because this is all of the points where m is greater than or equal to 80. This line and everything on the right. We'll talk more about it in a minute. I'm just kind of introducing the topic now that sometimes it doesn't matter exactly what you have, it just matters that you have that much or more, or simply sometimes just more than that. Let's do one more. Next month, Mr. and Mrs. Duncan decided to go out to eat dinner at a nice restaurant, and they've decided to put their money together to afford it. Say, I'm off the hook for the whole $80. Now we've got $80, but the two of us are going to put our money together in order to afford it. And so clearly that's going to be m plus p. That's my money and my wife's money together need to be what? Greater than or equal to 80. So once again, with the same counting by 20, there's 20, 40, 60, 80. M plus P has to be equal to 80. So it's not just that simple anymore. Remember, this is M, this is P. And so what I want to do is, as I normally do when I solve for Y, in order to graph this, I want to solve for P. So I'm going to subtract M from both sides. Now I have P is greater than or equal to negative M plus 80. Okay? So how do I graph that? Well, you have no idea how to, but I'm going to tell you to just, for a second, pretend that this is P equals negative M plus 80. Again, that might look confusing to you, but just remember that P is really Y, M is really X. So you should know how to do this one, because you just go up to the 80 on your y-intercept, right there, and your slope is negative 1, which means you go down 1 over 1. Because we're counting by the same scale, I can just go down 1 tick mark over 1, down 1 tick mark over 1, down 1 over 1, down 1 over 1. The line I should have would look something like this. In reality, it doesn't make sense for anything of the negative, but remember, I just graphed the line y equals negative x plus 80, or really p it equals negative m plus 80. But what I want to graph is p is greater than or equal to negative m plus 80. So there's one more part that we need to add in. Again, don't worry if it doesn't make sense to you. It will by the end. And what we need to graph in is all the stuff that can be greater than, which is everything on this line. Or everything above the line that I've just drawn. Because remember, the two of us together need to have more than 80 or equal to 80. Anything above it will also be a valid solution. So if I wanted to talk about this point right here, sorry, it's not showing up yet. If I wanted to talk about this point right here, that's where I have $120 and my wife has 80. That would get us to 80. So that would be fine, and that's a solution. That's why it needs to be shaded in. Now that you have an introduction to that, we are going to figure out how to graph these things. So graphs of inequalities are similar to graphs of let's try that again. Graphs of inequalities are similar to graphs of linear equations because they both have points on a coordinate plane and a line that connects the points. So we graph both of them using a line. However, a linear equation is only the line. So what we were graphing last week, the only solutions to those linear equations are the points on the line. But an inequality extends beyond that line in one direction or the other. And here you can see a linear equation and contrast that with a linear inequality. Notice the only real difference is my sign in between, an equal to as opposed to an inequality sign. All right, next, here are 4 different ways that inequalities can look, or linear inequalities can look. The first one up here is y is, let's try this again. Not doing so well. Okay. Now, this is y is greater than mx plus b. So greater than is what goes in that first blank. Notice all of the points that are shown, or all the points that are shaded, are above the line, and you have y is greater than. That's going to be important. Also notice you have a dotted line. That dotted line is the same as an open circle. Okay, remember our open circle meaning it can't be a solution? Same thing, now we're using a dotted line instead of an open circle. The next one, we have y is less than mx plus b. It's the exact same dotted line, but now we are shading in everything below that dotted line because y is less than mx plus b. The third one, I have y is greater than or equal to. Notice the same line as above, except it's a solid line. We now have a solid line because we have this less than or greater than or equal to. The equal to means I use a solid line. And once again, as I did in the one right above it, I shaded everything above because y is greater than. And then finally on this fourth one, y is less than or equal to. So notice what happens. I shade below, and I have a solid line. I shade below because I have less than. I have a solid line because I have less than or equal to. Okay, now let's go through a systematic way of doing this. First step on graphing a linear inequality. I am going to decide where the boundary goes. The boundary is the line that I'm going to draw. So I need to solve my inequality for y. Oops. So for example, I would try to get something like y is greater than 2x plus minus 1. What I want, though, is I want y by itself, so I can graph just like y equals mx plus b. What I'm always going to be thinking to myself is y equals mx plus b. Let me try to get it in a form that looks like that, even though I'm not using equality signs anymore. Now I'm using inequalities. Second, decide whether the boundary should be, well, for less than or equal to or greater than or equal to, I am going to have a solid line. Notice the solid is what goes on that second line. And when I am using less than or greater than signs, that's when I'm going to use my dashed line, or a dotted line is what I like to call it. So the points, for the solid lines, that means that points on the boundary, points on the line that I am drawing, are true. They make the inequality true. They are solutions. For a dashed line, that means points on my boundary are not solutions, okay? Or they make the inequality false. Third step, I'm going to graph the boundary line. And fourth step, I'm going to decide where to shade. I'm going to either, for y is greater than or y is greater than or equal to, I'm going to shade above the y-axis, or I'm sorry, that doesn't make a lot of sense. I'm going to shade above the boundary line. And for y is less than or y is less than or equal to, I'm going to shade below the boundary line. Do not write in that y-axis. That doesn't make any sense. Okay, so it's just 4 steps. First, graph my line. First, solve for y. Second, decide whether or not I'm using solid or dashed lines, just like deciding whether or not to use open or closed circles. Third, graph the boundary or the line. And 4, decide to shade all the points above it or all the points below it, based on which inequality we have. So let's go through a couple of examples and then we're done. Graph y is less than negative 2x plus 1. So I need to solve this for y. So I need to think y equals mx plus b. It turns out I already have it. So I'm going to try to graph the line y equals negative 2x plus 1, even though I'm really trying to graph y is less than negative 2x plus 1. So as usual, think about what my slope and my y-intercept are. My y-intercept is 1. So I go right there, and I put that point. And then my slope is negative 2. So I go down 2 over 1. Down 2 over 1. And I get this point here. Once I have 2 points, I can just connect them with a line. But second step, I need to decide what kind of line that line should be. Because the inequality is less than, the line should be a dashed line. So you notice I put in a dashed line here instead of a solid line. Next, I graph it, which I've kind of already done. I graph the boundary or the line. And fourth, I need to decide which side to shade, above or below. Well, because I have y is less than, see I have y is less than right there, which comes from up here, then I know I need to shade below the line. And so I'm going to use my highlighter. I just shade everything under the line because these are all possible solutions. Let's do one more. Next, I want to graph something. I want to graph 2x minus y is less than or equal to 4. Well, only one problem. I have to now solve for y, and it's not solved for y for me. So this should be pretty simple, a blast from the past. We've got 2x minus y less than or equal to 4. So I need y by itself. I'm going to subtract 2x from both sides, subtract 2x, and I have negative y is less than or equal to 4 minus 2x. Or rather, let me do it as negative y is less than or equal to negative 2x plus 4. Great. I still don't have y equals, though, because I have negative y. So what I want to do is just multiply everything by negative 1, which will flip the sign on everything, which will get me, to here. Y is greater than or equal to greater than or equal to 2x minus 4. Notice what just happened here. Notice I had this sign here, but what happens when you multiply both sides by a negative? The sign flips. You cannot forget that. That's very, very important. Okay, now we need to decide what kind of line we have. Well, because it's greater than or equal to, the line should be solid because I can equal that line. Next, I graph the boundary, which is, I'm really going to graph the line y equals 2x minus 4. So my y-intercept is negative 4 right here. And then my slope is 2, so I go up 2, over 1, up 2, over 1. Got a few points. I draw that line in. And then finally, I need to figure out which part to shade. I'm going to shade above the line because my boundary, because its y is greater than or equal to. Greater than tells me to shade above. So I simply take my highlighter, shade everything above the line I've just drawn, and now everything that I have colored in is a possible solution. So just to make that very clear, this point right here, and 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 this point right here because it's on the line, and that point because it's on the line, and this point because it's right above the line, all of those points I just drew in are solutions to this equation that I started with. If I plugged in the x and the y coordinate there, I would get a true statement. I am now done. As soon as you, oh, actually, I'm not done. I'm sorry. You're going to do this question on your own. You're going to try to graph y is greater than 1/2 x minus 2. And then we're going to answer this question together. Why are there dashed boundaries on some graphs of inequalities? Well, we've got 4 choices. Points on the line make the inequality false. Points on the line make the inequality true. The slope of the line depends on the line type. And the y-intercept depends on the line type. How in the world can I answer this question? Well, I'm going to go back to where I just learned it. What does a dashed line mean? Dashed line means that points on the boundary make the inequality false. It's the same thing as an open circle, whereas the solid line is the same thing as a filled-in circle when we were just working with one variable, but now we're working with 2, so we're using dashed and solid lines. So clearly, for this one, the slope has nothing to do with it. The y-intercept has nothing to do with it. It's that points on the line make the inequality false. My video is done. Have a wonderful day.